All right, so we're going to do one more video, one more on 4.3, which is, as you recall, we were dealing with the auxiliary equation and complex roots. And last video we went through kind of where the general solution comes from. Then we tried one problem, but I just think, even though I think you got it from here, I think I'm going to do one more of these guys. And I do want to make a quick comment. So if you feel like when you're going through this differential equation class, if you feel a little uneasy with some of the operations we do, like the way that we treat C at times, or the way, I mean, even if you think about when we had e to the RT, the way we can write that is t e to the RT when R is a complex constant. I get it. If the reason we gloss over a lot of the details is because of how unbelievably useful differential equation is to engineers and scientists, and what it is we don't have time to wait for our engineers to go through a bunch of mathematical preliminaries, the things that you would need to really have to address why some of these techniques work. We know that the techniques work and we know they're useful, so it's just we just want to expose the engineers to these techniques, okay? If some of you decide to go a little bit further in mathematics, you will find someone will at some point in time start to break down a little bit of this ambiguousness that we see from time to time. So anyway, so one more of these problems. So let me go ahead and read. So what we want to do is we want to find the general solution to the following second order differential equation. Now, the way it sits, you're not going to know if this is going to be using complex roots or real roots. Like we don't know until we've used the quadratic formula, or till we're able to look at the discriminant. We're not really going to know yet, see if it factors, say, what the solutions are going to look like. So therefore, we don't know which general solution to use. Now, I'm already penning the general solution that we're going to use for this problem above it. So I just want you to understand that what I'm outlining right now is not going to be in the questions on your final. You would have to do what I'm about to do to recognize that, oh, okay, this is one of these problems where I use this type of general solution. So let's go ahead and get started. So as you recall, the first thing that we're going to want to do is we can write it out as we're going to write out our auxiliary equation. So we would have A, in this case, is equal to 1, B is equal to 2, C is equal to 4, okay? And now I'm going to go ahead and move from our differential equation to our auxiliary equation. So with A being equal to 1, this is going to be R squared, plus B is equal to 2, so that's 2R, and C is equal to 4, so that's going to be plus 4. Okay, and still equal to 0. So you start off, you try to factor, you realize, okay, this is not factoring, so let me jump to my quadratic formula. In your quadratic formula, so we're going to have negative b, so negative 2 plus or minus the square root, and that's going to be b squared, so that's going to be 4 minus, and that's going to multiply that to ac, that's going to be 16, divided by 2 times a, which is going to be 2. Okay, so it's at this stage right here that you realize that what's inside that radical, that negative 12, is going to mean that we're going to have complex roots. We're going to need to use our imaginary notation. But more importantly, you should recognize that that means you are going to this form of the general solution, okay? So let me go ahead and go a little bit further. So this is going to be negative 2 plus or minus, I guess I'll come off to the side just to make sure. So let me erase that. I'll keep working down, so bear with me just a second. So if you have the square root of negative 12, clearly you can rewrite that as the square root of negative 1 multiplied by the square root of positive 12. And we have defined the square root of negative 1 to be I. So this is I square roots of 12. Now, normally what you would do is you would write the square root of 12 as the square root of 4 times the square root of 3. This would be the simplified, just like if you were writing 2/4, you would simplify it to a half. If you have the square root of 12, that can be simplified to square root of 4 is 2, so 2i square roots of 3. With me? All right, so that is going to be going in replacement for that square root of negative 12. So let me rewrite. So now I have r is equal to negative 2 plus or minus, and now it's going to be 2i square roots of 3 all over 2. All right, so at this stage, what you have to recall, and I'm going to write this up top because this is something that you can have written right beside your general solution. Just remember that we went through in the last video and we showed how we can think about r as in its complex form as alpha. Oh, that's a horrible looking alpha. Try that again. As alpha plus or minus the square root of 3i, right? So that's the complex form of that root. So that's the a plus bi. We have the real number part and the imaginary number part. Now, I don't know why I put a square root of 3. I don't know what I was thinking. I meant beta I. Okay? So what did I just do? Well, look up here at the general solution. So you would like to know what to plug in for alpha and as well as what to plug in for beta, right? Well, this is how you know what to substitute for alpha and what to substitute for beta. So let me go ahead and finish this. So I'm gonna take r. I'm gonna divide everything by 2. That leaves me with negative 1 plus or minus I. I'm gonna write it as it's I square root of 3, but I'm gonna go ahead and write it as the square root of 3i. And right now, I just want you to notice that this is of the form r is equal to alpha plus or minus beta I. Okay, so now you know at this stage that alpha is equal to negative 1 and that beta is equal to the square root of 3. Okay, so from here, I'm going to write the solution. I'm going to go ahead and jump right to the solution. Because hopefully you know at this point, you're just coming up here and you're plugging in for alpha and for beta. Now, do you understand that in this problem, we are not going to address these constants, C sub 1, C sub 2, because why? Because they only asked for the general solution, right? They would have to give us more information if they want us to proceed to the particular solution. So what is the general solution? I'm going to go ahead and write it here. So y of t is equal to c sub 1 e to the negative t times cosine of the square root of 3t plus c sub 2 e to the negative t sine square root of 3t. All right, so what I'm boxing in right now, let me just bear with me, make sure I didn't write anything silly. So, yeah, so what I'm boxing in right now is the general solution to this problem, and this will be the last problem from 4.3. So the next video, I just want to kind of give you an idea of where we're going, right? Because now that we're done with 4.3, when we first started chapter 4, if you recall, all of our I'll show you right here. All of our differential, our second order equations were of the homogeneous form where it was set equal to 0. Right? Well, so these were all special cases for how to tackle problems, to solve differential equations, but all of them required your second order differential equation to be set equal to 0. We now want to look at the situation where the right-hand side of the equation is of the non-homogeneous form, where it's some function f of t is what the differential equation is set equal to. So that's where we will pick up next time I see you, and I'll see you then.